Okay, there was some interruptions in the previous uh, video, so this lecture would be recorded in two parts or two videos. So again, it's very easy. This is okay. Now, first of all, I have to apply again AR2 is equal to 1 kip foot. It means the structure is, I have to be redrawn. For example, it's very easy. Okay, this is member AB and this is your another member. So when you apply this 1 kip foot of moment, that would be balanced by a pure moment. Again, that joint would be balanced in equal and opposite direction, and that would be again balanced by equal and opposite direction. It is same as the analogy is same to that of simple frame. For example, you have a frame here and the frame is like this. So if you can balance here with equal and opposite moment, and then you can balance it with equal and opposite, because this is clockwise, so you can balance it with anti-clockwise, and then you balance it with clockwise moment. So moment should always be balanced with the moment. Like I have done it, applied 1 kip foot, it has balanced with this 1 kip foot. This joint is balanced again, and then this 1 kip foot is balanced here. Constructing the moment table, it's way for easy. And for AB, okay, this is your A, and I have to find all moments here. Now this is a clockwise moment, so it would be balanced by equal and opposite, and this is anti-clockwise, -1. It is in Z direction, so MC. Here this is anti already, so it would be balanced with equal and opposite clockwise, +1. So it's here. Here it is a torsion, I have to balance here, so torsion would be balanced here. So this is anti and this is plus, so this would be +1. So that's why it's +1 here. So it all needs a practice. Okay, this is even more simpler. You have applied this 1 kip foot moment. This is your redundant action 3, so I'll balance it with equal and opposite 1 kip foot, and then I'll balance here with 1 kip foot, and I'll balance it with 1 kip foot. Sections are X and this is X, and sectioning is done like this. Okay, you should know that this is A, this is your B, and this is your C, and again this is B. For BC, your origin is C, so I have to find all moments here. So this 1 kip foot is minus, and this is in Z direction, so it would be balanced with +C, 1 kip foot, +1. That's why it is +1 here. And the moment, this moment is in X direction. You should know this is Y, this is Z, and this is your X. That's why it's under MX. For member B, and for example this was your point D, because the sectioning would remain same as that of original structure. For this, this is -1, this is y-axis, this is my x-axis, and this is my z. So this is, you should know that this is anti-clockwise. All these moments are anti-clockwise, so this is minus, that this is -1, so it would be balanced here with +1, and this member is in X, this moment is in X, so this is a torsion, +1. Similarly, this is +1, it would be balanced by equal and opposite, -1, because this is anti-clockwise, so it is minus. As the moments table has been constructed, my next job is to calculate DRL1. So for DRL1, you should know that I have to, DRL1 is equal to M into M1 dx divided by ei. And if torsions come, t into t dx divided by gj, and you should know gj is equal to 0.8 ei. Acha. Okay, now if for let me see my table for AR1. Okay, this was my AR1 and this is my table. So I can see that there are lots of value mx, there is some value for mx under bc. For AD there is values for mz and tx. For BD there are value for mz and tx, and for BC there is only mx. So my point of concern is this mx, mz and tx. So corresponding values, if exists in original table, would be multiplied. So I can see here, yeah, this is z square. Here under BC row under mx I have z square minus z square, and here BZ mx I have a z square, so it would be multiplied. Also I have mz here, tx here, mz here, tx here, here mz here, tx here, mz here, tx here. So there would be lots of calculation in DRL1. So I have done it. Yeah, the DRL1. This is the limit of the section. Length, member of length, length of the member, length of the member, length of the member, and you have to integrate it. For example, for instance, let me show you in the previous slide that minus z square has been multiplied with z under the limit 20 0. It means yeah, this 20 minus z square has multiplied with z, and again 20. Also when torsions multiply, for example this minus 20 is being multiplied with this 400 into minus 20, so it would be multiplied by gj, and which is equal to 0.8 here. So I have done it here. Yeah, this is 0.8 ei. So very simple, you can go for DRL2 as well. For DRL2 again I have the values. If for mx this moment table has to be multiplied with the moment constructed for AR2. So this is the table. So I have no value here, it would be empty, but there back in the original M table there are some value corresponding to these two. However, there is no value here, so there would be only two terms, because under AD row minus 1 and BD there is a plus 1 under MZ, and you can see here MZ, these two values exist. So when I go there and I can find out DRL2. Similarly you will be finding DRL3, and flexibility matrix is very easy to find. It is, it's very easy. And flexibility matrix, for example this F11 would be found out using this equation. So if this is for let me construct this. This is AR1 is equal to 1. This is the table. So if I calculate F11 here, it would be equal to number 1 this x minus 15 square divided by ei and dx. The limit is 10 to 0, so 10 and 0. Next this, so I'll get minus 20 square. This is tx, so I'll write tx here. It would be divided by gj or 0.8 ei. The limit would be same, that is 10 0. Okay, next I have this, so x square divided by ei into dx. The limit is 5. This is the length of section. 20 has to be multiplied with 20 square ei. Again this is torsion, so this would be 0.8 ei. Limit is 5 0. Finally this z dz, the limit is 20 0, and divided by ei. You have to solve it. So you will solve it and you will get this value. Okay, so f22 is very easy, f33 is very easy. This is related to self multiplying. However, I'll find f12 because this is for ar1 is equal to 1 and this table is for ar2 is equal to 1. So I can easily find f12 which is equal to f21. That would be equal to, okay, let's find. Here I have x minus 15 and here I have minus 1. These two would be multiplying. X minus 15 into minus 1 dx. This is moment, so ei under the limit 10 and then 0. Next I have this plus 1 and I have a corresponding value x. So x would be multiplying with 1, so no matter, I should not write 1. So okay, ei and limit is 5 and this is 0. Finally I have this plus z, but I have no plus z here, so this would be equal. So you have to find it. You have to integrate it and you will find the value. So I have find the value for you. f12, this I have multiplied 3 value probably here. There should not be any third value. Yeah, there is no value. mx, there is no value here. Probably I'm wrong here. Tz plus 1, f12 should have two values only. Yeah, it should have two values. Here I don't know why it is more than one value. 20, yeah, 20 is 0. It is 0, so no need. Yeah, it is okay, it's correct. So he has multiplied 20 with 0, so it's okay, it's correct. Okay, you will find f13 on your own. It's easy. So you can find, okay, you should know the flexibility order. The matrix should have the order 3 cross 3 because there are 3 redundancies. So f11, f12, f13, f21, f22, f33, f23, sorry, f31, f32 and f33. And you should know that f12 equal to f21, f31 should be equal to f13, f23 should be equal to f32, and these are diagonal and they won't be equal, and they won't be equal to 0. This is a property of a flexibility matrix, and this is the same property which stiffness matrix has, and you will be studying stiffness matrices later. So should I do f13 or something? Okay, I can. I'll do it for you. It's very easy. Let me do f23. Let me find f32. For example, f23 would be equal to f32. Let me find. So I have to multiply it if there exists any value, corresponding values there for this. So I see that here I have values for tx and here I have no values. Finally I have value tz is equal to 1 here, and here I have no values. So f23 is 0 probably. Yeah, f23 and 32 is 0. So it's very easy. You can see. You can see here it is equal to this. This is f13 and it would be equal to f31, and other values are equal as well. They are non-zero values. Okay, and I have a simple formula to calculate the AR. This is the mathematical model. You have found out the flexibility matrix, and you have the DRL matrix, and you should know that the order of this matrix is 3 cross 3, and the order of this matrix is DRL1, DRL2 and DRL3, and this is equal to 3 cross 1, 3 rows and 1. So in order to multiply these matrix, the number of column, okay, you should know that this represent row, this represent column, this represent rows, this represent column. So now in order to multiply these two matrix, the number of columns in first matrix should be equal to number of rows in the second. So it is satisfying the condition. So these two can be multiplied. So finally, using the Excel, you have find this. This is very important. The reactions, I have calculated these reactions, and I want to calculate these reactions for you as well. I mean, this is very easy and very conceptual. So okay, let's do it. What for example, I have this and I have this. Okay, I have this as 31.70. I am remembering 31.07. Okay, next let me open my notes because I cannot go back and forth. So give me some time. Okay, this, and I have this moment as 37.60, and you have this as 198.7 kip foot. Now you have a load. I have a load, and the load is UDL, and the UDL is, for example, 2 kip per foot, and this is 20 feet, so 40 kip. The load acting from upward is 40 kip, and it is balanced with 31.07. It means I have to apply 8.93 kip load. 8.93 plus 31.07 gives us 40. I'm actually balancing it. Okay, this 37.60 would be easily balanced. It would be balanced here, equal and opposite, and it would be balanced here. So I am done with it. The only problem is that I have to calculate some moments, and the moment here is to be calculated very keenly. For example, I want to calculate this moment, so let me use another pen. I want to calculate this moment, and let me clear it. I mean, it's very messy now. Okay, and this is 198.7. The load is 2 kip per foot. This is 20 feet. This is 31.07, and this is 8.93. I have to find this moment, mx, and I have assumed it to be anti-clockwise, so minus mx. Okay, then this 190, I have to find all moments here. Okay, minus mx here, this is plus moment in x, so let me write here 198.7. okay, this is y and this low member is in z, so it would also form a moment anti-clockwise, minus 31.07 into 20. And finally, the upward load is forming a clockwise moment. You don't need a resistive concept here. You can do a follow a resistive concept here, but there's no need. It's so simple, 2 into 20 into 10. And when you calculate, you will find an mx. and you will realize the mx value would be negative. It means the assumed direction is wrong, and actually the value of mx comes out to be 22.7. So you can see here I have found 22.7 kfoot. Okay, finally, this 22.7 is just balanced here with 22.7. However, this 196 moment is to be found out. So I can found it very easily. For example, I don't know what moment it is. So this is moment in z direction. So I assume it to be plus mc. Okay, you should know that this is also a moment in mz and this is nt. So I can write minus 37.60. This 8.93 is in y, this member is in x. So this is also forming a moment in z clockwise. So I'll write plus 8.93 into 15. The distance is 15. Then this 10 kip is also forming a moment clockwise. So 10 into 10. So you will find that mz would be plus and this magnitude would be equal to this. I think you need a little practice, and it is same as the concept from basic mechanics. Likewise, for example, you have a moment of 10 kfoot and you have to find a moment here, and then you balance all moments here, you find a support reaction, then you transfer moment here, you balance here with equal and opposite, and you find a moment here. So I don't think so that this is very difficult, but just you have to recall the basic concepts, and the basic concepts are very easy and simple to follow. So I think this is the first question on grade. I'll be doing another question, and inshallah I hope I think you should ask a question. I mean, you people don't do assignments as well. You are at home. I know it's a very freak situation, and everyone is at home. But I think this situation would be over, inshallah, because I mean there is no nothing is permanent. Everything would be changed. So I mean, in next 2 3 months or even a year, things would be all fine, and you would be regretting that I could not study this. This is the very basic and very advanced course. I mean, if you are able to learn this at home via my lectures or using any other source, YouTube or anything, I mean, you will enjoy it because you would be able to comprehend many other courses ahead. So I wish and I hope that you take an interest in this subject.